Okay, hello everyone. Today I will be doing the ninth project in the Arduino starter kit. It's titled Motorized Pinwheel. So it looks like it's basically gonna be using the Arduino to spin this motor, and then yeah, that's basically it. So things that are different about this project is that we need to use a 9-volt battery. This is probably due to the fact that the computer can only bring in 5 volts, and we probably need more than 5 volts for the motor to run. So the good thing is the starter kit comes with what's called a battery snap. Which is this guy. And it quite literally snaps onto the battery and lets you plug it in to the power rails of the Arduino or of the breadboard. So then you can power your circuit that way. So how that works is line it up and you snap it in. Like so. And then you can use these wires, plug in. So, what we're also going to be using today is a new device. It's this guy, which is known as a MOSFET. What a MOSFET does is it basically it acts as like a gate, a logic gate, or basically if one pin, the controlling pin, the gate pin, receives a certain amount of voltage, then the source and the drain, the other two pins, are connected, and then it just acts as it lets the voltage flow, and if not, then it doesn't. So it's used a lot in circuit designs such as regulators, which shunt regulators, in which you're saying I only want like 5 volts to go into my circuit and I want nothing more. And then you can use these MOSFETs to guarantee that. So even if 10 volts is being supplied, only 5 volts will go into the circuit. Things like that. These are used for. They're also used for like half wave and full wave rectifiers, which can make it so it's your sinusoid voltage input. It's only going to be like positive or negative values of voltage instead of like the full wave, so it just cuts off half of the wave, or it reflects that half up, which is important because when you start looking at average power and stuff like that, you want to you want to actually have an average that's not zero, a non-zero average, because the average of a regular sinusoid would be just 0, and that doesn't help you all that much sometimes. So, but that's more complicated theory. We're also going to be using a diode, which is functions exactly like the LEDs, except it's not gonna light up. Hence, it's not a light emitting diode. It's just a diode. So it just controls the flow of the current through the circuit. So yeah, let's get started then. So we're still going to connect the power and ground from the board, like so, like we usually do. But like I mentioned earlier, the big change is we're going to plug in this 9-volt battery. So red to power, like always, and black to ground. So let me see if I can get the battery. There, battery's in frame. Okay, so we're going to be using a push switch, I guess, to turn the motor on and off. So let's plug that guy in, and then let's do our typical switch connections. So first, one leg goes to power. Then we need to connect the other end to our board. So we're going to use pin 2. So, and then we need to put a resistor in series, a 10k ohm resistor, as we want to ensure that we don't short out any of our certain elements. Just not sure why they don't go directly to ground with this one resistor, but we'll follow what the book says. Do it the way that they instruct. Okay. One end of the battery fell out. Looks like the wire could use a little bit of a stripping to so that I can make a better connection, but if that continues to be a problem, then I'll try and find a wire stripper. Okay, so that's connected to ground. And next let's use our MOSFET. So let's see. The left pin is the gate pin, and then the middle pin is the drain, and then the right pin is the source pin. So if this part is facing back on the back side, then this pin is the gate pin. Okay. So I've actually studied these MOSFETs quite a lot last year, but I've never actually been able to do anything with an actual MOSFET, so this is kind of cool. Supposed to do like labs with MOSFETs, but since schools went online due to current circumstances, didn't get the chance to do that. I just got to simulate what MOSFETs do, which is still educational, but not as fun. So this is pretty cool. So we connect the the source to ground, and then we are going to connect the drain to the motor. So it looks like the Arduino is connected to the gate pin, which makes sense because then we're gonna probably code something so that the board will tell the MOSFET when to turn on or off, and then when it's on, then I'm assuming the connections, the way it's made, will make it so that the circuit is completed, and then it'll the motor will turn on. Just realized my picture is wrong. Let me change that real quick. Okay. So we're almost done. Next, I need to connect the MOSFET to the motor. So, we are going to be using the diode. So let's do that. Looks like the diode is going to power, and then we're gonna have the black end of the motor connect to that same node, and then the power also going to the power, or the red wire going to power, and then lastly we just need to connect our grounds to make sure that it's all the same ground node, so it's not just different, which is important. So yeah, it looks like that's it for the hardware. Some pretty cool stuff. Yeah. Okay, wait, I need to make sure that my diode is connected the right way, because yeah, there's the anode and the cathode, and it looks like the stripe end is the cathode. So the anode is connected to the ground of the motor, which is this black wire, which is good, and then the cathode is connected to the power of the motor, which is right here. Okay, yeah, so we did it correctly, even though wasn't really paying attention to that detail, but anyways, yeah, so let's move on to the coding. Let's see this, Arduino. Okay, let's make a new sketch. Looks like the code is going to be short and sweet today. So as always, we are going to declare our pins. So switch pin equals 2. And then motor pin, which is also the MOSFET gate pin, equals 9. And then we are also going to declare our switch state variable, which is always good to do. Cool. And then in our setup, we must declare our inputs and outputs. Pin mode, motor pin. So the motor pin is a output because we want it to turn on and off. So output pin mode. Oh, I don't know what happened there. The switch pin is going to be an input, as we are going to read whether or not the switch is pushed or not pushed. So cool, done that. Now to our main function. So we're going to read the switch pin. So switch state equals digital read switch bit, like so. And then getting to the logic part. So if switch state is high, so if the switch is pushed, then we will digital write to the motor pin high. So we will turn the motor on if the switch is pushed. Else, we will turn the motor off by digital writing motor pin low. Okay, and that looks like that's it for the code. So we still have to plug in the board so that we can upload our sketch. So let's do that. Project 9. Cool. And yeah, hopefully this will work. So let's change this back to this scene. Hide one of these since we don't have our other two. So I don't know if you can tell, but when I push the button down, the motor goes on. Let me see. And then when I push it off, it stops spinning. So I believe we can find stuff in the kit to like play with the motor, as in like actually show it turning something better. Let's see. I see. Okay, so they do have a special device here. Yeah, so let's try and put that together. It's going to be using these orange plastic that the kit comes with, these guys. So let's quickly put this together. So it looks like we snap one of these pieces is marked C. I don't know, they all look the same to me. Yeah, so it looks like this guy with the two wide pins, I guess, go in first. Just push it in to this circular one, and then this guy will go right on top, looks like. Okay, and then I guess this is the pinwheel thing, so then we can push that in. Okay, let's try it. Oh yeah, it spins. That's pretty cool. That's it. Yeah, I wouldn't recommend touching it. It spins pretty fast. It's yeah. There you go. We made a pinwheel, motorized pinwheel. Kind of cool. Thank you for watching the 9th part of my Arduino starter kit video series. It was a pretty cool project in which I got to play around with some devices that I studied last year, but didn't actually get to physically play with. So yeah, that was really cool for me, and I hope you guys enjoyed this project. It was a little bit of a shorter one, which was fun still, but the next project should be pretty exciting as well. So make sure you if you enjoyed this content, then like, subscribe, and follow the Twitch channel, and where I will be doing it live on probably on Thursday. So please look forward to that, and yeah, I'll see all of you in the next video. Thank you for watching.